Geoffrey is going to facilitate next session, which is going to be summary reports from our discussion groups. Jack, please.
These are discussion groups. They are also actually work groups, and they have work product, and they're going to present them in order. The first group is the breakout group number 1, data and metadata, and the representative is coming forward right now. Thank you.
Okay, so we've had a very productive session with very good ideas on a very, very difficult topic about the data and the metadata that we want to make available. So let's first have a look at the challenges because they're substantial. The first thing is that what do we know about this data? What can we expect about this data? Well, the first thing we know is that n equals 1 right now. There aren't that many data sets out there. For the omics data sets, we have 1. For the more self-recorded data, there's also only 1. One would hope that we could aim for, say, n equals 100 in the future, but that's definitely not on the timelines that we were given to consider. A second problem is heterogeneity, and that's also for the future. If we're going to get data like this from 100 individuals, are we going to get them from a single focus project with a single source of funding that's going to maintain and enforce standards top-down? Or are they going to be from 100 disparate groups or 50 that each are going to do their own little thing? Because then we're going to be in a lot of trouble. So obviously, we should push there to try and get uniformity at the level of the infrastructure and the support to get this done. And then the toughest challenge right now is that this is a very young field, and it's very hard to predict what the actual data will be. We're constantly coming up with new instruments, new ways of monitoring and tracking things. And so we have very little idea of what actually will be tracked, say, in 2 or 3 years from now. And right now already a lot of people are tracking different things about themselves. So to make that worse is even what we know is out there today is very hard to disseminate and interpret. So there's self-recorded data, people who are using apps or using a diary to keep track of certain things. But that data is sporadic, it's subjective, especially the stuff you write in a diary. What's a headache? You know, is your headache the same as mine? What's a severe headache? And it's inconsistent. People only report their symptoms if they're looking out for something. They may not report other things that they think are irrelevant. So it's different between individuals. Now, there are ways to tackle this. You could, for instance, try to use Bayesian methods or whatever, but you need enough data. And right now, I don't think we're there. And it's very difficult to collect the data. The data may be out there, but how do you collect it? How do you get it together? And that, again, is a longer-term project than just a few months. Now, people use smartphones or electronic devices like step counters and what have you. And so that kind of company-obtained data from personal electronics is more consistent internally. The problem that you have there is interoperability. Everybody uses their own proprietary way to format the data, so you really cannot carry it across. And then the omics data, so we can think the Mike Snyder type data here, is typically much cleaner and more structured. But there we have the problem that even though we can obtain it from a lot of bigger studies that have actually looked at many people, the phenotypic data is typically missing. So we have the data, but not the context. And if you want to get the context, you have to do it per request. So you have to go out and ask for the data. And even then, in certain cases, because of privacy issues, you may not be able to get particular types of data, and that's a hindrance. And that's a very, very fundamental problem that also goes with electronic patient records and what have you. It's not unique to what we do here. Okay, so enough griping. What are the plans and what are our key elements for success? We think that the only way to tackle a field that is so light on its feet, it's changing so much all the time, is to try and get together a bunch of people to do this. And rather than say we will build a community, we think we should determine whether we can build a community. Is it possible to already today coalesce people around this topic to get together and work on these challenges? And we really need to have a mix of current generation, think tenure track scientists, and next generation scientists. These are the people who do the work. They're the PhD students, the postdocs. We need to give them both something. We need to give them some carrots to join this thing. How do we want to kickstart this community? By setting a challenge, a project. Give them something vertical to work on so they can build on all the different levels of infrastructure, but all towards a common goal, because otherwise the heterogeneity of their approaches is going to make everything not interoperable. And there, of course, Delta Breakout Group 3 has the ideas there, we hope. And so the idea is that the challenges or the projects will drive the infrastructure development rather than the other way around, because that typically does not work. If we say, here's a lot of infrastructure, now do something with it, it's not going to happen. If people say, I want to do this, and the infrastructure does not exist, you build it for them, that'll work. So the key elements here are to use the right technologies. We put 2 down for which we can see uses, but there is data right now already out there that doesn't fall neatly into these categories. So I have to put 3 dots as well. New infrastructure has to be developed there, RDF and Void. And then there's another problem that I will very briefly touch upon that we discussed as well is licensing. So you want to, for instance, on RDF data, you want to license the information at the triplet level. Then reciprocity of use. So you want to aim for reusable components. People who contribute have to bring it back. If you want to build a community, steal it from an existing one. Try to get a biohackathon together to take some of the data, transform it into RDF. It's something we can do today. There are projects that have already done it in the past with existing resources, which is pretty neat. So there's examples, there's prior art. And finally, we need a scientifically relevant use case that motivates and inspires people. Sorry for running over time.
You did very well. Thank you. Just stay up here.
Our charge was basically to discuss the metrics and evaluation in 2 different parts. One was the suggested metrics for the first 3 months. It's more inward looking and making metrics for DELSA to make the downloaded data more useful. And the second part is basically it builds on a strong feedback connection from the analysis results into DELSA. So if that's not there, basically we don't need to even talk about metrics and evaluation for that part. So it's an outward-looking part. So in the discussion, what did we see? The existing data, there's the Snyder data and SMART data, and they all have different levels. There's the raw data, and there's different levels of this data. And basically, all of these need to be there, and all of these need to be in a form that's useful. And we couldn't talk about the metrics without talking about the process. So you see the data here is coming in. And then it goes into this downloadable platform and it gets downloaded for different analysis. And from there, the goal is basically for this outputs to go into downloadable data archives, or maybe the results in a better case go into peer-reviewed journals. So there are metrics here all over the place, but Plan 1 involves these metrics in the download piece for sharing and analysis, and Plan 2 involves metrics for analysis and data sharing through public archives, and also metrics for publication. So plans for sharing, inward-looking one, before everything happens, basically, DELSA probably should take care of the download rate and communities that are using it, intent of use. And also there needs to be some strong policy development. What will be happening to the results of this data? Are they going to cite DELSA data as citable? And that also has a big analysis part, of course, because this data is not compatible. The types are not compatible. In time, the time resolution of this data, maybe you can't compare data collected in different parts. And maybe some topical things or analysis parts that will not be matching. So DELSA needs to clearly show the users how these, in that sense, coordinate with each other. There are many dimensions there probably. And in the Plan 2, then let's say the data is downloaded, then we are moving into the byproducts of this data. Reproducibility should be a matrix, and contribution to existing analysis capabilities. Is this data actually triggering new data analysis tool development? And publication citations should be there, and meta-publications. You know, can we cite all the data sets that are actually generated based on the data that is downloaded from DELSA? And the metrics for data sharing, then the same things apply: provenance, reproducibility, download rate. This is actually a little bit more inward-looking too, because we are assuming maybe some of the feedback for linking to this data is there. And there's openness, accessibility of the data. If it's downloaded and the results are shared through a public archive, can we assume it's going to always be there? So these are also relating to the storage metrics. And do we have enough storage in the long term? And the last slide is metrics for publication of it. They should cite the DELSA data as the origin. And the feedback needs to be incentivized. So then we talked about the actions that DELSA needs to take to basically come at this. And incentivizing feedback is the first thing. And the most obvious way of doing it is maybe offering some publication opportunities on the cumulative sum of the data analysis products. And also, I think that also has a unique opportunity here across domains in terms of cross-domain analysis. Based on these published results, you can actually identify one original data set and come up with all the analysis products of that data set across domains. And then you can create basically a network index across domains, across scientists, across data, across the pieces of the original data. And you can do some interesting analysis on this. And that would be the value, in that sense, that also would provide to the community, because there's an original point there. 5 minutes, 16 slides.
All right, so this was a group on scientific outcomes, and the group was that, oh, we don't have these slides, but so I'm presenting on behalf of my colleagues on the scientific outcomes, and they're welcome to comment on the discussions. So we were tasked to discuss what scientific outcomes and questions should be answered by these two unique data sets. And what we realize is that we're also limited by the metadata and the phenotypic data that are already collected. So although there are a number of disease-related phenotypes, much of the data are also so-called sort of normal phenotypes. So we coined a term and called it normalomics, meaning that sort of physiological traits such as change in blood pressure that may fall within the normal range, but that are often sort of not studied in terms of their inter-individual determinants of these kind of phenotypes. And this is a good bulk of the actually the phenotypic data set. So while we should look into disease-related phenotypes, I think we cannot afford to overlook this rich potential phenotypic outcomes as well. So that's an actionable item in our review. There is also diabetes, Crohn's disease, and influenza type of events that were recorded in these two data sets, at least in some cases. There is also the issue of clinical utility versus personal utility in this kind of domain. It's all often discussed in the context of clinical value or clinical relevance, but we shouldn't forget that there is also a personal utility of this data. People can use it for different kinds of outcomes, so we have to consider that as well. In this data set, in terms of actionable outcomes, there are also drug-related events that were monitored, and they can also be easily related to some of the multi-omics data. There was a paper that was published 2 years ago in this new field called pharmacomicrobiomics that's relating to microbiome data to inter-individual variability in drug-related outcomes. So drug-related outcomes is one of the outcomes. And another related one, so that we don't box in our scientific outcomes only on diseases, is the nutrition-related outcomes, as well as some of the intermediary endophenotypes that are available in this rich data set. So there's a number of other items, but basically we also have to pay attention to compare the outcomes between these two N of 2 data sets, essentially. So that will be an important axis of analysis. So that was the first question that we were tasked. The second question was actually 2 parts. It was about how do you return the results to Delta, and the other part was from Delta to the broader community. And we thought that the first time frame, which is, we have a 1-year time frame now, approximately, the first 6 months will be about analyzing on the outcomes that we're suggesting, including some normal outcomes, and then reporting them back to DELSA. And the format would be in a way that will engage a variety of users, communities, and the analyst communities. It can be through a web page format, web portal, or face-to-face, or it can be crowdsourced. And there are different steering or governance mechanisms, such as a prize contest, to facilitate this process. So DELSA could create, for instance, microgrants, a concept that we'll also discuss later on this afternoon. There's issue of validation, because here we're talking about, in a way, both discovery and validation. It's not always an easy task, and we have to also be aware of the incidentalome, and that oftentimes information can also be harmful. Now, the second milestone will be the last 6 months. In other words, the second half of the envisioned year will be disseminating the results from DELSA to the broader community. We thought a layman's summary of the findings would be very important to reach a broader audience, so that this will require a certain number of skills, such as public affairs skills, messaging skills, in a way to distill down this information that can be understood by a broader community. A micropaper concept has been discussed. We did not want to sort of drill down too much into this because this also has to be debated, but that's something to consider. Analysis tools need to be put in a form that can be used also by non-professionals, not only by scientists, so that's a task. And then we need to develop alternative models of publications as well as courses. Thank you. Justin.
Thanks, Jack. Our group had kind of a fun assignment. How do we take this new science, this new area, and communicate it out to the broader public and try to get some engagement on that side? We had a really creative group, and the group came up with the idea of creating a YouTube video competition on going out to particularly the community and asking them why they would like to be quantified and what they hope to learn from it. The videos would be submitted in several categories: best K through 12, best adult, which could be a parent as well, best physician, best scientist, and best overall. We thought that would be kind of a fun way to do it. What we propose for the first 6 months here are just some baby steps to figure this thing out. One suggestion is to define what is a quantified human and update Wikipedia on that, because I think it's still all over the map. Another suggestion is being able to update an FAQ, so that would be tied into the video competition. So Jack had some great ideas on that side. Define the competition, basically the rules for submission, prizes, etc. And then also explore partnerships. So community members that might be interested in supporting an effort like this by way of education and outreach. That could also be for not only near-term funding for running the competition, but also looking at sustainability funding for it. And we also thought, not that we could commit Larry or Mike to do something, but it'd be really nice if they were involved, or we had other representatives from the community explain, why they wanted to be quantified humans and what they hope to learn as a way to kind of stimulate the discussion and competition there. In phase 2, we know that we really do need to implement the competition, so that's going to require real work, websites, and all this other kind of stuff. We'd have to look at, again, actually moving from identifying potential partners to securing a partner to do it, and funding and sustainability would be essential. But we also came up with a huge number of ideas for expanding something like this. So planting this first seed could actually yield a lot of really interesting ideas downstream. That was it.
You're under your time limit. Well done.
Because during one of our DELSA calls, Gene sent out this vision published by NSF for the cyber infrastructure. It's about a year old, and he says, very important, we should all read it. And I said, hey, we should do a workshop on that. So I got to lead that workshop. Everybody should join the DELSA calls and volunteer for something. I think that's a good thing to do. So going through that, it has a lot of the technical things that we talk about with sharing data, issues around taxonomies, big data, and all of these really general high-level issues. Linda actually said, how many have sat in this room, in a similar kind of room and come up with a similar kind of list? And so as we talked that through, what was the big issue? And it's really, it's going to boil down to the sustainability models. If the government can't just fund these things and make them available forever. And we've heard sustainability come up a few times, and that's going to be one of the big challenges to overcome. And in particular, when one's thinking about the value of data, as we talk this through, one of the issues is that value is going to change in different ways over time. So some data, I saw one that, we could have little thumbs up, thumbs down, how often data gets used. Well, if you look at that in the context of today, you may not be recognizing that data could have value down the road. And so we need to really think about these models as being adaptive and flexible, and and there's a lot of models in the world that map to this. And so if you break it down to some of the issues, facts, and solutions that we came up with, and I'll let you decide which is an issue and which is a fact and which is a solution. But it's public-private partnerships are going to be absolutely critical to sustainability. Databases, data sets actually benefit by aggregating around nodes in a network. So this is Metcalfe's law. So for those of you who don't know, that is, a node's value increases exponentially with the size of the network. And I didn't know that either, but thank you, John, for sharing. And the social issues are really going to be some of the big thorny issues, and they're really going to revolve around the individual, because the data set, when we talk about human health, is about the individual, and that'll need to be dealt with. And so there's a lot of things around the cost and value allocation. So data can be expensive to collect, but cheap tomorrow, expensive today, expensive to store, or, all of these things can change as we work through this. And then, some of the business models we can think about, micropayments, freemium models. There's a lot of things that DELSA can contribute in terms of thinking about how to make data sustainable. So we didn't really come up with a 3- and 6-month plan, but the real role for DELSA is about enablement. So how do we really think and act like a startup? How do we bring together the appropriate data consumers? These would be prominent individuals who understand the data needs and values. Work with industrial data managers, Google and Amazon. So how do we get that meeting with the CEOs of these companies, with perhaps leaders of some of the major institutions, to really have a proper dialogue, and then develop, and then also we learned we had a recovering doctor and a recovering lawyer, right? So I said, well, we need a recovering economist, because I think a lot of these things, what could they bring to the table in terms of our thinking for value, and then also venture capitalists in terms of the risk-reward model that would go with these sorts of things. So DELSA's role would be coming up with the talking points to engage and get these meetings set up in a good way to move it forward. So we didn't come up with a hard timeline. We're volunteers. So, all right, thanks.
Thank you. Great. So we have about 27 minutes to improve upon the work of the 5 groups represented here. And it should be noted that the work will be ongoing over the next 3, 6, and 12 months, and that each of these actually ties into one another and informs one another. So the most useful content that we can get now from you all are specific pointed suggestions to make all this work even more robust. Floor is open. Great, thank you. And let's follow the practice of identifying ourselves, please.
I'm Nina Pruce with Turner Consulting Group, and we have the nitric.org project, which interacts with neuroimaging scientists, and they share data and collaborate and things like that. And my background is really MBA in marketing, so I got to join the outreach group, which was very exciting. And Think Like a Startup really is about, I don't know what you've done already and have in place, but we talked about a marketing and outreach plan, because if you're going to go reach out to partners to figure out how to leverage their relationships to disseminate, information about our competition, right? Those are the same people you want to reach out to talk to about all these other topics that are in all the other working groups. So you really want to have a cohesive plan so that when you're going to Google, you're talking about all your topics, not just the one from the one working group.
Great, excellent point. Thank you.
So there's a parallel with the sequencing the human genome. We got Craig Venter's genome, which I think we realized was not a particularly representative genome. And so we went from there to the 1,000 genome project through some intermediate stages. So one of the things to think through here too is we have a personal genome, different approaches of 2 individuals. Is this meaningful? So then some plan for moving on to the 1,000 whatever or the 20 whatever, just to see what are the lessons from the individual to a smaller group. They'll be all individual genomes, but do we, all this hard work, just end up proving that everybody's different? I actually already knew that.
Excellent, thank you. Let me just invite the panel members to comment on either those observations and/or things you heard from each other. Anybody want to make a comment? We're still, oh, yes, please.
Yeah, so I think actually Bill's point is well put, right? So this is why my first bullet, my first point on my slide was n equals 1 right now. And even if n equals 100, what does that mean? So that's a discussion that we had as well in the data metadata group, is that you have two kinds of studies. You can do the study that goes across individuals on a particular data set. But you can also have the longitudinal view on an individual. And I think even though that's not something for the next 6 months or even the next 2 or 3 years, that's essentially where we should probably go for in medicine. There are so many markers out there today that are used commercially or functionally in the clinic that PSA is a prime example. That doesn't say anything by itself. But if you track it throughout your life, which isn't done because it's too expensive, but then we heard things get cheaper all the time. This kind of longitudinal data will become part and parcel, I think, I hope, of clinical practice. And then we can start doing these kind of things. And then, does it then really matter? And how much does it matter that everybody's different, as long as you can compare somebody with himself or herself yesterday? So.
And, we're going to kind of bounce back and forth. So, John, it's yours.
So, two quick implications of those comments with the N of 1. One is that in clinical care, everybody will be an N of 1, but in order to better understand how to treat that N of 1, we need to look like genomes like me, okay, and multiomes like me. And so there's a market for startups right now to basically be able to create a slider bar that says, okay, I need them to look like me in these 100 parameters. Oh, that's too few people. I'll take 50. Oh, that's not enough. I'll take 150. And basically be able to pull from a very, very large data bank of Ns of 1 to create a larger N that's meaningful enough for the study, but is related enough by specified parameters that are relevant to the question at hand. I think that until we get to that understanding of how that's going to play out, it's very hard to convince people to donate their genomes to science. I think when you start explaining that to people, the value proposition to the individual participating becomes very high, because the more value they will get from contributing their genome both to science as well as to their medical record.
John, let me just test something. I've just had a very mundane pedestrian idea, which is that there's a crude analog in what happens in pricing a home for sale, which is you look at comparables.
Right.
They're never exactly the same home,
Right.
but you get a sense of where you ought to be.
Yeah.
Good.
No, that's a very analogous.
Okay.
But I think that the critical distinction is that the N of comps is incredibly high, and your ability to use a slider bar to say, I'll take 50, I'll take 100, I'll take 150 similarities is really qualitatively unique to the genome.
Yeah, of course.
I was just going to add, though, in real estate, it's location, location, location. So the genome value can change where you live.
Good. Vural, yours, and then we'll come back to the mic. Please.
Just to follow up on the two comments prior, I think we had the 1,000 genomes. We have the N of 1. What's really missing are the points in between. We really don't know what is the minimum sample size, for instance, that has utility to extract some meaningful information. So we had these two extremes, it seems, N of 1 and 1,000. So as this kind of data set moves forward, I think we'll have some answers to that. And the second related point is, this is also about study designs. We had a lot of emphasis on between subject variability, but these data sets are really time series within subject data sets. So it will, I believe, inform us about optimum study designs. Do we go between subject, within subject? What is the sweet spot, if any?
We're going to do back and forth. Please, go ahead.
Hi, thanks. I think it's exciting, some of the ideas that I'm hearing about what you're creating as a data clearinghouse, from what I understand. and that you want to excite people through YouTube to contribute to this clearinghouse. But what I'm not quite hearing or understanding is how you're going to, once people download the data and do the analysis, how you're going to excite them to re-participate and come back to either critical discussions or posing new questions around this data. And I think for sustainability and for future growth of DELSI, that's probably a component that you might want to think about as well.
We did have some conversation about that within the public communication group, and I'll let Rob comment on a sense of trying to manage the scope of our effort within the early stages. But go ahead and say whatever you. Keep going, Jack. Well, all right.
You're on a roll.
I think there was enthusiasm for doing that kind of thing, but some sense of the modesty of our resources for the near term. And so now it's going to be okay.
So on the point of n is equal to 1, also I think there are multi-scale challenges there in one individual that we don't necessarily know all the answers for. So studying one individual would actually give us maybe some ways of doing it. The data is of a resolution of n at the temporal, spatial, and molecular scale. And so I think computationally there are a lot of challenges there at one individual that needs to be solved before we can go to larger numbers of people.
Thank you. Sir?
I wanted to come back because I did use the word genomics. The trouble is with genomics, we can only measure disease potential. We're not measuring the phenotypic state. So to your point, we have the technology for genome sequence. We have pretty good bioinformatics capacity. We just don't have the technology for high-throughput proteomics. Metabolomics a bit better, and we haven't developed the bioinformatics tools yet. But this is really what we should be measuring, not disease potential. If somebody's got a BRCA1 mutation, have you got disease? No. You've got a certain potential. It doesn't tell you whether to get treatment because you don't have disease.
Right.
I'll just add with the exception that there's a lot of omics that are measured with genomics technology. So the whole transcriptome and coding and non-coding. And the non-coding is going to be very, very important in terms of some of the disease states.
Right, but that's, again, predictive. Just because you have transcript doesn't mean you're going to get the protein. Quite often the transcript doesn't get made into a protein, yeah.
Please.
So I think that's a very good point, actually, that the genome gives you a predilection or a certain chance for getting something. But that could actually be used in a very meaningful way as well, right? So you can triage a priori who you're going to monitor for what. And the downstream technologies like proteomics and metabolomics, and to some extent transcriptomics as well, are vitally important to check what's actually going on in you at the point. But you would not screen an entire population in that way for everything. So what you would do is you would use genomics, of course, and then just work on smaller groups. And that could actually be, and that was a point that came up in my group, which is why I'm saying it, is that would also be a way to work with smaller and then still get meaningful results. It's if you get the right people into your smaller groups of, say, 100 or 200 people, it could still be meaningful if they're very focused and not just, any random individuals that you can collect.
Gene, you're always welcome at the microphone.
We don't have enough of me. I'd like to actually to get a opinion from panel, and of course everybody here is on one specific point with regard to what we have right now on the second line about public-private partnerships. I think it's definitely critical for sustainability of life sciences research. And specifically, how do you see that's happening in ideal case or in minimal, kind of mode for this specific quantified human data quest for next year?
Are you looking at the industry guy? Well, there's probably a few mechanisms, right? So definitely, the pharmaceutical industry, as a clear example, is doing a lot of academic funding today because they've wound down a lot of their internal R&D, and they found that for pre-competitive kinds of applications and technologies, it was much better to do those with that kind of partnership. So you always have to balance the rights to publish and the interests of the academic science and benefits to society against your goals as a business. But that as a model, I think is very successful around data, instrumentation. There's a variety of these things that they're happening. It's finding the successful ones and then figuring out how to generate a model and then go after folks.
We've got a couple more responses. Vural, and then just thank you.
I think in terms of public-private partnerships, we'll see emergence of new tools of governance of those kind of relationships. The usual model has been somewhat risk-averse and to some degree for understandable reasons. So you have to have, for instance, proof of concept. It's possible or conceivable that the proof of concept model will change because you had to show that and you could establish a partnership afterwards. In this kind of data, we have a lot of uncertainty and what they call in economics unknown unknowns. Those kind of variables don't lend themselves to classic proof of concept model to establish a partnership. So we have to rethink what uncertainty is and what risk is. Because as things stand, if we use a proof of concept model, the partnerships may not materialize.
And so in the data metadata group, we talked mostly about infrastructure for these kind of things. So the licensing, I glossed over it and still went over time, but I'll go into a little bit more detail now. So one of the things that will be important is how do you license your information? For instance, you cannot enforce something like a GPL style license where we make everything open, therefore you must make everything open. You could envision, but for scientific purposes, that's actually not too bad because then you ensure that the community releases back to itself. But we thought about dual licensing and also the reuse of the data. If you dual license it, there is the benefit that everybody can get a taste of the data, even a commercial enterprise. And that was a point I think that was put forward that was very strong point is that people tend to only value the data after they've looked at it. They only realize what it is and what they can do with it once they've had a chance to play with it. So a dual license approach would allow that. So you would be able to play with the data, even run a few queries, do some analyses, and then suddenly you figure out, whoa, there's something here. And at that point, you can switch the license. And you can say, I want to develop a commercial product or service on top of this. And then at that point, you decide to pay for it, and then it's fine. So that's something that's quite important. Inversely as well, suppose you have data that is somehow federated, okay, maybe not structured federated, or you have a cross-resource queries. Some of these resources may be private resources. And that's why we had this licensing at the level of the individual data element, as atomic as possible. You can still do queries across this. And then at the very end, you can decide whether or not you can check all the licenses that you've touched upon with your query and see whether that's compatible with what you want to do. Or you could a priori eliminate all data that does not license freely enough for you. So these kind of infrastructure things can be built into this data. The systems can become hideously complex, that must be said, so it can be a problem, but it is, at least in principle, not an issue to take these things into account, and they should be built in from the start, right? Because we don't want to preclude the work from companies, but nor do we want to aim specifically for them. And so especially this dual licensing was a very good idea that came out from the discussions in my group.
I'd just like to observe that in my mind, it occurs to me that public-private partnerships may be a little bit limiting in terms of the nomenclature. And we should be open to thinking broadly about potential partners in this enterprise. Patient groups and advocacy groups, for example, might well be important partners for some aspects of what we're talking about.
Well, that was because you mentally limited public.
Right.
But no, it's a very good point. The other
we tend to think in terms of, well, who's the industry partner we can look at?
Yeah, exactly. And the other I think very important example that's emerging is around diagnostics, and today it's around personal genomics, but there's a lot of conversation about how to share data across organizations and companies. And if you look at, there's 300 to 600 diagnostic companies all doing different kinds of measurements, and that would be very interesting data to be able to roll into these kinds of systems.
So we got 10 minutes left. We need some hot ideas or some pointed questions that will stump our expert panel. Thank you, please.
I was not here in the morning. Sorry, I had a couple of meetings. Sanjay from EMC. I'm the other industry guy, I guess.
Great. Welcome.
Well, there's
so, Just a word of caution. I think WebMD and Google and Microsoft tried this with personalized health records and failed. So I think instead of thinking as a startup, we should be thinking more like a contract research organization, looking at clinical trials. Because empowering the person and keeping the person empowered for a long period of time is a very hard thing to do. So just a point of observation.
That's useful.
Yeah, so choosing the right person, what I'm trying to say, is more important than figuring out what kind of data you're getting back and forth. It is consistent behavior over a long period of time that's very hard to do. So, especially if you're taking data sets that are somewhat complex. Most of personalized health records were 200 clinical data points. Here we're looking at several million probably data points. So that's just an observation.
Great, thank you for that. Any comment on that from the panel? Okay, please come on up.
I guess I'm a little confused because when our subgroup met, we were talking about the quantified human, and I just went back to my notes, and I see here quantified cell is 7 to 10 years, and quantified human is 15 to 20, and the ecosystem is 20 to 30 years. So I think it's really important that the 3 to 5 year plan be very clear when you go to those public-private people and talking about partnerships. Here we're going to do some video thing about quantified human, but we're not planning on having real data and insights for 15 years. We may not be doing the right thing,
I think that timeline might need a little bit of explication. So, Gene, you want to take that on?
That's actually one of the, one of the obvious examples of versioning, okay? So right now on one page you have this timeline, okay? And on the page I showed you in the early morning, it was much shorter, okay? So we did talk to our steering committee, we talked to people from social research about human capability, if I'm not mistaken, to over-predict within short time and under-predict within long time. That's why we changed this timeline, okay? So it looks like from research done on social sciences, we are the best as a group, predicting within 7 to 8 years. Up until 5 years, we are usually over-predicting, and 10 or more years, we really under-predicting, okay? So this timeline you had is old version, and new version is much shorter. Quantified cell, we think 5 to 7. A quantified human, we think 7 to 10. And quantified ecosystem, 10 to 15. And I think, point here is that they're very much overlapping. It's not one after another, They're going to happen more or less simultaneously, but, we think that those are deliverables. And this is up to discussion, because that's another iteration of reality we've got.
But Gene, we don't anticipate having to wait until
we don't.
The end of that to get insights and benefits.
No.
And let me just take the opportunity to say, on the New York Times most frequently emailed list today is a really wonderful piece by Michael Pollan, a food writer, about his own. It's called "Some of My Best Friends Are Germs," and it really is a first step forward in terms of communicating the potential of this kind of science to a broader public. Please, sir, go ahead and tell us who you are, please.
Sure. Harsha Rajasimha. I just founded a startup, Jiva Informatics. I'm a bioinformatician. So the startup ideas, I can take some of those. But what I wanted to say is, in addition to the diseases that were listed, I don't know what the mode of thinking was in suggesting diabetes and a couple other diseases there. But in terms of quantifying a cell, cancerous cells, give us an opportunity to understand the cell cycle mechanisms, what's wrong in that cell. Why not include cancer is one question. Another is rare diseases, in addition to common diseases, offer a great opportunity because it has minimum perturbation, most likely, because rare diseases tend to have a single or monogenic mutation more often, and so they offer us take that first step towards understanding monogenic disorders before we can tackle the common diseases. So in that sense, I would like to piggyback on your suggestion about patient advocacy groups. There is NORD, the National Organization for Rare Disease, who may have a integrated database of rare diseases samples and data from across the world that we could probably gain some kind of access. And our virtual data-based approaches are more valuable in these instances because of the geographic dispersion of these patients and samples, which is more easier in the common disease scenario. So more impact or value could be demonstrated with rare disease.
That is very helpful and interesting. If I understand you, you're proposing that the common assumption, which I would certainly make, that rare diseases are more challenging, actually may be more amenable to the kind of analysis we're now talking about doing. Very interesting. Thank you. Great. Any comment on anything about that? Gina's handily put up the Michael Pollan article. Fascinating reading. I recommend it. We have enough time for 4 more brilliant ideas. This group is capable of doing at least 8. Who will rise to the occasion? Please.
In the last group, Think Like a Startup, and I just want to say anyone here who has resources to bring to the table in terms of contacts and people who meet that list at the end of what we need to bring together and other people would be really helpful to start gathering those resources together.
Great, good point. And yes, thank you.
Maybe just following up on that comment, I'm seeing the picture of Angelina Jolie there.
Yes.
And maybe she would have been interested in quantifying her own health state as a way of mitigating potential breast cancer issues for herself.
And
I'm saying this because she's a high-profile person.
Indeed, yes, she is indeed, and potentially also as an advocate for the power of advancing this so even more sophisticatedly prudent prevention strategies can be put in place for those who need them. Did I see a hand over there? Well, let me conclude with just one observation. I'm enthusiastic about all this. I'm especially enthusiastic about the public communication part because I think it's important. But also I think it can deliver benefits to the whole enterprise in more than one way. One less obvious way that I just want to note is was brought to my attention by talking to a guy who ran an oceanographic lab, very interdisciplinary. And he said when they had undergraduate research interns, they found a couple things that were interesting. One was the undergraduates tended to ask really, really dumb questions, which turned out to be very interesting. The second was, in order to communicate to these undergraduates, these very interdisciplinary scientists, or scientists working in interdisciplinary teams, found that they had, in order to talk to and help the students understand, they understood each other better. So we welcome you to join and be part of any one or more than one of these working groups as we proceed. And with that, I think our session is closed. Thank you.